discussed resultant force. So I'm gonna go through some more into more detail, okay? So let's say we have this object and it has a force acting on the right hand side. Let's say 5 Newton, and it has a force on the left hand side as 0 Newton. So I can write RF as 5 minus 0, which is nothing but 5 Newton in the right hand direction. All right, but let's elaborate this a bit further. Okay, since it's taking me a lot of step actually. You see, let's say I have a question. Let's say I have this particle and it has a constant acceleration and it has a mass of, let's say, 2 kg. It has a right hand side force of 7 Newton and it has a left hand side force of 9 Newton. That's it. So practically, if I solve this, then this is the lengthy process. Okay, this is the lengthy process. So I'm going to show you the short process in a bit. So as usual, I have to find RF, which is nothing but 9 minus 7. See, this is the driving force. Okay, you have to understand this. This is the driving force. This is not the driving force. Why this is the driving force? Why 9 Newton is the driving force here? Because 9 is greater than 7. So obviously, this particle will move in this direction practically, if I think. All right, no matter where I'm giving this acceleration or whatever the direction of the acceleration is. Okay, in this scenario, the acceleration will be here in this direction. Okay, you have to understand this logically. Let's say, so according to my math, the acceleration happening is on this direction. All right, so RF is equals to nothing but 2 Newton. All right, so the question is to find find A. Let's say find A. So here I know my formula, F equals to mass into acceleration. I know my force, which is 2, and I know my mass, which is 2, and I know my mass, which is 2, A. Hence, 2 is equals to nothing but 1 meters per second squared. All right, but let's say this is the lengthy process. Let's write down the formula F is equals to ma. Again, I can break down this formula as driving force minus backward force is equals to mass into acceleration. So this can be a formula, the new formula, dF, or I can write forward force as well. I can mention my driving force as the forward force here, minus resistive force or backward force. Okay, resistive force or backward force. So by using our common sense, I can say on a road, if I'm moving forward, the opposing force is friction or air resistance, and the forward force is and the forward force is I am overcoming these forces. This is my forward force, okay, or my driving force. All right. So let's say we have another situation coming up. Let's say I have this particle and the acceleration is not given and the mass is 2 kg. My driving force is 3 Newton, and my backward force is 7 Newton. So according to the formula, I can write driving force 3 minus 7 is equals to mass into acceleration. 3 minus 7 is minus 4, 2 into A, minus 4 by 2 is equals to A, minus 2 by A. This negative sign means the particle is not accelerating, it's decelerating. Now, I know it's a bit confusing. So what happened here is that this is my backward force, okay? So backward force is my air resistance or friction. So if I have to walk forward, I have to overcome this 7 Newton force. But common sense, if I apply 3 Newton force, it can never overcome the 7 Newton force, which is acting backward, which is opposing the driving force. Hence, common sense, it's decelerating, it's not accelerating. Okay. So a very common example of decelerating is the braking force. When a car brake, okay, it's decelerate. Okay. So this is the resultant force part 2. I know it's a bit tricky to understand, but once you see the overall examples in the upcoming videos, it will be extremely clear for you. But you have to understand this formula. You have to understand this driving force minus air resistance or friction is equals to mass into acceleration. This formula is a must to understand for the upcoming videos. Thank you so much.